Right, so I'm going to start looking at the metal, so actually deforming the original geometry. And we actually need to do this whole thing another couple of times. So I need to get the original mesh at the position frame 77, but only these metal bits that I'm going to bend. And then I also need the rest of the body. Obviously we've removed a lot of it there at frame 77. So I'm just going to copy this whole thing, well, with the pointer form actually, copy that, and then jump back into my body fracture. Okay, so for the metal, so at this point, right, let's just paste that down, and then I think if I just drop that across, get rid of the trail. So this is basically the car with this geometry, after splitting everything out at the right position. So that's ready to be deformed by the simulation geometry, right? So let's just drop a null under here. Call this out car pre-fracture. Okay, and then I'm going to do the same thing over here for these pieces, which is what's left over, okay, which is not going to be deformed or simulated in any way. So we'll just call these rigid pieces. Okay, so we've got both of them, so that's fine. And then I'm going to jump out here and make a new geo. Let's call it body wheel post sim. Okay, and then a different color. We're doing a different thing again here, yellow. Okay, and then dive inside and then find both of those. So we had, that was in body fracture. We had, so body, let's see, car pre-fracture. I want that. I'll be dealing with that first, and then, but I'll get them now. Rigid pieces as well. Okay, and then we'll also need the actual simulation geometry, or simulated geometry. So that will be from body wheels sim, out body wheels sim. So we've got our fractured geometry there. So that's great. So we can take a look at deforming this metal now. Okay, so that's the pre-fracture, and we're going to be using the RBD deform pieces. Okay, so these are the geometry, okay, and proxy geometry, right? So proxy geometry is your simulation geometry, and then your geometry is what you want to actually deform. So if I just visualize that now, you actually get something that's okay. Okay, a bit of a problem though is a few bits, so these kind of weird jagged lines, but hopefully we can address that. So I'm going to do a few things here. So let's start. I'm just going to unpack this. So that should give us a better result. And transfer, we need the name for this whole process. Okay. And let's see. I'm going to delete everything except for the metal, because we're only deforming metal. Is bendy. Okay, deletes non-selected. Okay, let's see how that looks. Okay, it's getting there. So yeah, we need an attribute here, a cluster attribute, to say each piece, to identify each separate piece. So we're getting kind of a how to describe it, like a bleeding between these two separate pieces here. I want this geometry piece, or the simulated door, to only deform the door of the original geometry, not this piece, right? So we use this cluster attribute to do that, and we do have, if we look here, this class attribute, but that's an integer and it needs a string attribute, right? I think it even tells you here, or maybe not, no. Maybe in the help it tells you. So what I'm going to do is just drop a wrangle oops, a wrangle here. Okay, and generate a new attribute from that class attribute, right? So we'll call it section. S at section is, and we use this function I to A, which will convert an integer into a string attribute. Okay, and then what we want to change is I at class, and that's it. Simple as that. And we do that on primitives. And if we do the same thing on both sides, okay, because they were set up the same before, and then take that section name, come in here, paste that in there, and that should help us out a lot. Let's take a look. There we go. So we're seeing a difference there already. You can see they're not kind of, don't get those weird jagged edges there. Looks much better. Okay, more things we can do. We can play around with these values. I'm going to push this up to, well, I'm going to leave it at the default for a moment while I address an obvious problem, which is the subdivision of this piece at the bottom. Okay, let's just name this as well, actually. Section, let's just call it that. And this was ISO bendy. Okay, and yeah, what we need to do is just use a divide to add some subdivision to this, right? What we can do is just select by class would be fine. Enter on that. Okay, and then I'm going to excuse me, turn off the convex polygons. I'm just going to set this to manual because it can be a bit slow. Use these bricker polygons. Okay, and then set this to 0.01. 0.01. Okay, and then set that back to auto, and they'll give me a load of boxes there. I was trying to match it up to the division that we see here. Okay, so we get a similar deformation. Okay, so let's take a look at that now. See, it takes a bit longer now as we're, you know, moving more geometry. Yeah, so as I said, we can play around with these values. The rest frame, that's actually wrong. That needs to be 77, as you know, that's the start of our simulation. So I'm going to do that. I don't know if, well, it seems to not have had an effect anyway. And then I'm just going to push up this value, maximum points. So how many points can it take as reference? Let's push that up to 300. And that should have quite a bit of an effect. You can see that smoothing everything out there quite a bit. Okay, so that, whoops, that's pretty much it. Let me bring that back. Great. One thing I do notice is, you know, this piece poking out in the middle there, and this piece is on the inside of the door, and from our camera we're not going to see that. So I'm very kind of lazily, I suppose, or, you know, a sneaky trick is just to delete it, and there we go, it's gone. Problem solved. Simple as that. Okay, so that it's either doing that, or I don't know, it'd be kind of complex to try to bend it more, or, you know, we'd have to do that in the simulation itself, which would be a bit of a pain. So that's looking quite nice now. We could quickly do these pieces as well. So we need to kind of drive these pieces with this now, right? So we're going to use yet another pointer form, using a whole load of these in this lesson. Okay, so this needs to go into here, I think, or above. Well, it doesn't matter actually. And then we need a time shift for the rest. And again, that's going to be frame 77, beginning of our simulation there. Okay, and then this stuff in the side, and that should hopefully follow along nicely. Doesn't look so nice right now. That's because I'm blasting it there. Let's do that. It's important that the rest and the actual, you know, the geometry has the same number of points. That's why you get all those crazy values. So there we go. So if I move that back to frame 77, okay, you can see it moves, and maybe if we can just quickly merge these together, just take a look. Oops. not file merge, merge, grab, what happened there? Oh, did I just delete the point deform? There we go, just grab that and this, and they should line up nicely. So if I just pop forward there, you can see, so all the pieces are following along. Jump forward again, we're getting that deformation, and you know, we just need to add in the wheels now.